We are just going to talk about the basics, what's happening under the hood, so how you can pick the right framework for you. So let's get started. So the challenge is to have one code base for every platform. So most of the apps, especially for mobile phones, the Android and iOS apps are really the same. It doesn't make sense to have the same code, the same business logic written twice for the same app. So we are thinking of having a single code base for every platform, and we can even share the logic with web and desktop. But mainly we use cross-platform frameworks for Android and iOS. Okay, so we have some real-world examples, like Instagram uses React Native. We have Google Ads using Flutter, and we have Netflix using Kotlin Multiplatform. So we are going to talk about those three frameworks. So this is just a timeline. So React Native, the first release of React Native is in 2015, and it's backed by Meta. It was Facebook back then. And in 2017, we have Flutter from Google, the first release. So it's the second generation, let's say, of cross-platform frameworks. And then we have Kotlin Multiplatform, which is backed by JetBrains mainly, and also a bit by Google. So Google helps because Kotlin is the language of Android. So Kotlin was first developed in 2010, something like that, but it was only supporting JVM, Android, and JVM in general. And in 2020, it was multi-platform. Okay, so before we start, my name is Mohamed Rejeb. I'm Kotlin developer. I've been working with Kotlin for 4 years now, mainly on Android and on cross-platform development as well. Also, I'm an open source contributor, so I have some libraries on GitHub and some projects there, so you can check it. Okay, so let's get started with the compilation and architecture. So we are going to see how each framework is compiling the code. So what's happening behind the scenes in the compilation. So first, let's get started with React Native. What's happening is that we have a JavaScript code, the same as React works. So we have a JavaScript business logic, and we have the JSX for the UI, which is an HTML or whatever. And what's happening is there is a bundler which is going to bundle all the JavaScript code in a single JavaScript bundle. And then this bundle is going to be packed with the APK or the IPA, which are the native executables for Android or iOS. So we have basically JavaScript code bundled inside your app. That's how React Native works. So when you think of React Native applications, there is JavaScript code inside running. And how this works, we have a JavaScript VM. So there is JavaScript engines similar to the engines in the browser. For example, in Chrome, we have the V8 engine. So React Native has its own engines, which called Hermes, which is optimized for React Native. And what this engine is doing is like interpreting the JavaScript code, and it's calling the native code for that JavaScript code. So it makes you able to run JavaScript code, which is just-in-time compilation. So yeah, that's how React Native works. And we have a bridge between the native code and the JavaScript VM. So we have the native application and we have the JavaScript VM, and they're communicating with each other with a bridge. So basically, we have like two worlds, two apps in parallel. So yeah, that's in general. So that's how React Native works. We have the JavaScript source code, which is going to be bundled in a single JS bundle and packed with the APK or APA. And then this JavaScript code is going to run in the JavaScript VM. Okay, now let's move to Flutter. Then we are going to make a comparison, of course, for each type of compilation. So for Flutter, it's a bit different. We have a Dart source code. So Dart is the main language that we are using for Flutter. And then the compiler is going to compile this source code to native binaries. So we don't have a higher level language here, but we have native binaries that are going to be executed by each target. So we have binaries for Android, ARM 64 or something. So it depends on the architecture of the CPU of the target that you're using. So by having these native binaries, we have better performance. So it's way much faster than JavaScript code, and we have a minimum size. And since there is a compilation happening, so we can have target-specific optimizations. So we can remove things to work faster on Android. We can change things to work faster for iOS, for example. So we can have different optimizations for each platform. So which makes Flutter faster than React Native. Okay, so now let's move to the third framework, which is Kotlin Multiplatform. So here, it's the latest one, and it uses a different approach. So what's happening here is, like, there is, you can say, a multi-target compilation. So for Android, which is basically JVM, so Android is JVM after all. So let's think of JVM as Android. So what's happening is that the Kotlin code is going to be compiled to .class files, which is the JVM bytecode. It's the same as Java. So that's what happens in Java. So we are doing it the same way as Java. So it's native, actually. Kotlin is native in Android. Okay, so for iOS, we're using LLVM to produce native binaries. And those native binaries are going to work on iOS and can be called from Objective-C and Swift so easily. So it's highly interruptible with Objective-C and Swift, which are the native languages for iOS devices. And we are going to see later how this interruption is happening and how we can call Swift from Kotlin or Kotlin from Swift. Okay, so last for WebTarget, we are just compiling Kotlin code to JavaScript, and we have JavaScript files. So that's the only way to access the web. Well, actually, there is WASM also. Yassine mentioned it. But just now, like, we're going to talk only with those three targets. But yeah, there is WASM as well. Okay, so that's the Kotlin compilation. So we have the Kotlin code. It's going to compile for each target. It is going to compile 3 times. So for Android, the output will be .class files, for web, .javascript files, and native executables for iOS. So this is our app here, and this is the Kotlin code. So the Kotlin code is inside our app. There is no bridge. There is no 2 different apps. It's just inside our app. It just works the same as the native code. So that's the difference here. Okay, so now we are going to talk about native communication. So we talked about the compilation. This will make us understand how to communicate with native code. Or because in Android, for example, if you are going to show a permission dialog or to pick a file or to do any platform-specific functionality, you need to call native code. So that's an important thing. First, for React Native, as we said before, we have like this JavaScript VM and the native code, and there is a bridge in between. So that's how calling the native code is happening. So we have an asynchronous bridge, and it's adds some overhead, and it's adds some latency. It's not the best for performance. Also, we need to write code in 3 languages. So for example, if you want to do something specific for Android and iOS, we need to write the Android code in Kotlin, which is the native language for Android, and the iOS code in Swift. And then we write some glue code in JavaScript to have everything working together. So sometimes you will need to work with 3 languages to do this, which is not the best case. The same in Flutter, like we have platform channels. You need to write specific platform-specific code. So you need to write your Kotlin code in your Android code in Kotlin and your iOS code in Swift, and then you will have a communication with platform channels. So you can call those platform-specific codes using Dart. So the same way, you need to learn 3 languages, and mostly even in job like in Flutter jobs or React Native, you have to know Kotlin and Swift because you will need them to implement platform-specific implementations. Okay, so now let's go to talk about Kotlin Multiplatform native communication. It's a bit different. Actually, Kotlin is the native language for Android, so you don't need a third one. And for iOS as well, you can call the native iOS APIs using Kotlin. So actually, you don't need to write Swift code mostly. Okay, so let's explain this, and let's go to the demo, and I'll show you. Okay, I hope this is clear. So This is the Android app. So let's go to the Android code, and I have this app file. It's just an empty file. I can just write a new function here, KMP demo. And let's say that we have a Java library that we want to call, and I have a Java file here. We can have Kotlin code and Java code side by side. And yeah, I have a Java class, and I can just write anything. I don't know, maybe void test something. And then in my Kotlin code, I can just call that Java helper class and call that function, which is test. So, and it's going to work. I'm not sure now what's happening, but so I'm not good at Java. I think the syntax is wrong, but that's the idea. At least I've created the class. So, and then we can navigate from, like we can see that this Java helper is used in Kotlin, and we can navigate between the classes. Okay, so let's jump into iOS. And the same way, I have Swift code and you have Kotlin code, and I can have Swift files and Kotlin files side by side. So if I go to, for example, this coin helper, for example, so I can write a function, call it platform, which is going to return the name of my device that I'm using, and I'm returning a string, and then I'm using an iOS specific APIs. So this UI device current model is actually an API provided by Apple, by iOS, which returns the model of the device that you are using. And I'm calling this from Kotlin, so I don't need even to have to do this in Swift. And yeah, I can call Kotlin code from Swift. So I have a Swift file here. This is a Kotlin function, the start function, I can call it, which is this one. I can even write a new function, so new, and I can go here in the iOS app, I can call this function, and yeah, it's going to work, and it's totally interruptible. So that's how easy it is to use native code in Kotlin Multiplatform. So it's like the same language. So it's like calling Kotlin code from Kotlin code. Okay, so yeah, here is some comparison between those different frameworks. We have the code optimization, which means we have the source code, how we optimize this source code in compilation. So as we said, in React Native, there is no compilation happening. We're just bundling the JavaScript. Maybe there is some compilation for JavaScript code, but there is no platform-specific optimizations. So it's actually moderate, and we don't have a lot of optimizations. But for Flutter and Kotlin, we are compiling the code into native binaries or some kind of other formats, and we are doing a lot of optimizations there. Okay, so for build time, actually React Native is way much faster in build time because there is no compilation happening, just JavaScript is going to be packed into the application. And in general, JavaScript is fast in compilation in comparison to other frameworks. So for Flutter and Kotlin, it's going to be a bit late, especially that we need to compile code multiple times for each target. So you need to compile it for Android, for iOS, for desktop, and so on. Okay, so for native communication, for latency and overhead, so React Native, that's not the best thing for React Native. So Flutter and Kotlin have a better performance in native communication. So if you want to build an app that has a lot of platform-specific APIs, the best option is to go with Flutter or Kotlin. Okay, so, sorry. Okay, now last thing, we are going to talk about UI rendering. So we've talked about compilation and native calls. So the last thing is UI rendering. So how each framework is rendering the UI. So for React Native, it has this native look and feel. So as you can see here, the components are not the same. So if you have a button in React Native, it's going to be transformed to a native UI element on each side. So the UI components, the look and feel will be native for React Native apps. But the problem with this, it's not pixel perfect, and you can't have the same UI for both Android and iOS. So you're going to write something, you will have two different results on Android and iOS. So if you want a native look and feel for both platforms, the React Native is the best choice. For Flutter, it's rendering using Skia or Impeller. In general, it's using a graphics engine, so it has a blank canvas, and it's going to draw the application into that canvas. So this way, we have a better performance, a GPU accelerated rendering, and also we have a pixel perfect rendering. So there is no difference between the components in iOS or Android. We will have basically the same application. It's the same for Kotlin Multiplatform. Actually, it's using the same. It's using Skia, and it's using a graphic engine to render the UI into canvas. But there is something special here. So the approach taken by Kotlin Multiplatform is that it's not one for all solution. So you don't have to use it for all your application. So you can have it as a part of the app. So you can, for example, share a piece of logic and have the rest of the UI and the logic natively. You can share all the logic and keep the UI native. So you can have two native applications, and you just share the logic with Kotlin Multiplatform. And you can also go and share 100% of the code and share the UI and the logic. So it's a bit more flexible, and this helps teams to adopt Kotlin Multiplatform for their existing apps. So if you have two existing apps, native apps for iOS and Android, you can just start integrating Kotlin Multiplatform for new features. So you don't need to write everything. You can just go with this first approach and start creating new features in Kotlin Multiplatform. And yeah, you can just keep your old native code in native languages. Okay, so for UI, we have for performance. So Kotlin and Flutter has better performance since they're using some high-performant GPU engines, and for graphics engines, sorry. And for consistency, which means the UI is going to look the same for different platforms. React Native is not consistent, as we said. It can be an advantage and it can be a disadvantage. It depends on your need, actually. So if you need native look and feel for each platform, just go with React Native. Otherwise, go with Flutter and Kotlin. So which is what we have here. So a native look and feel. In React Native, you're going to get a native look and feel. So what we mean by native look and feel, the components are not the same for iOS and Android. So Apple has its own design system. Google has its own design system. So each company has its own design system. So yeah, that's what we mean. So iOS users are like, in their mind, they're using native iOS applications, and that's the look and the feel that's the experience that they want. So if you want a better experience for your users, make sure to have a native look and feel for your application. Okay, so to conclude, which tool is right for you? So it depends on the team. If you have an existing team that knows JS and React, so it's the best option to use React Native. It doesn't make sense to learn a new language and to waste time. Otherwise, if you have experts on that, I'm not sure if this is the case, but then you can go with Flutter. And if you have teams familiar with Kotlin, with Android development, you can go with Kotlin Multiplatform, which will be the best option. Okay, and here we are going to talk about performance. So for React Native is moderate to high. It depends on the case and usage. But for Flutter and Kotlin, they have better performance. For UI consistency, as we said, for React Native, you have a native look and feel. For Kotlin and Flutter, you have a uniform custom UI, the same UI for all platforms. For code reusability, all of them are using the code, but here we have a bit more reusing code for Kotlin Multiplatform, because, as we said, there is the native communication is easier, and you don't need to write code in platform-specific languages. The ecosystem, all of them are they have a strong communities, and they have a lot of plugins. So yeah, there is a strong ecosystem behind all of these frameworks. And for the project, so if you want an excellent dynamic native feel, just go with React Native. If the app is Flutter is great for design-driven apps. So for applications, when you have a design, you have a Figma design, and you want a pixel-perfect application, matching that design as fast as possible. Kotlin Multiplatform is better for complex applications that uses a lot of platform-specific APIs. So it's going to give you a more a better experience with using platform-specific APIs. Okay, so I think you can take a picture for this diagram, which will give you a better understanding of what you should use as a framework. So what we have here is, do you need the app as soon as possible? If yes, what's the team background? If it is web, use React Native. Other, just use Flutter. So if no, you don't need it as soon as possible, what is the type of the project you are building? If it is a new app, if you want it fast, go with Flutter. So as you can see, so Flutter is related to fast development. If you want performance and native integration, go with Kotlin Multiplatform. If you want to reuse the application on web, go with React Native. So this diagram is just answering some questions to choose the right tool for your application. So yeah, I hope you understand more about those cross-platform frameworks and how to choose the right tool for your project. Thank you, everyone.